Hello everyone, good evening. Welcome for the next session. So here we are back with another session on 150 must do questions. So I hope everybody is ready for this. So as you all know that we are less than 3 months from the exam, and this is the crunch time, and we must be looking at questions based on concepts which have been tried and tested again and again. Also some new style of problems, I would say something new, based on the past that we have seen. Every year we see something new coming across, something being asked in a very new way, right? So with that being the theme, right, these sessions we are bringing to you, right? It's a mixed bag, because now we must be through with all the concepts, and now we are testing ourselves to the greatest extent, I would say, right? So without further ado, good to see you, fun world. uh, let's start with this session. Here we go. Just to let you know that Career Launcher mobile app is there for you to help you in your preparation, so make use of it, right? It's available on both iOS and Android, right? So another one of the many ways to get connected with CL. All right, so here we go, people. Question 1, percentage. So let me remind that how we take this session. I give you a few seconds to absorb the question, to go through the gist of the problem, and after some time I start solving it for you. But the idea is that you try to solve it faster than I can, right? So whoever gets it, will get some, will get their name announced, right? We'll discuss, uh, you know, your name, and so whoever gets it first, that means that you people are alert, right? Okay, so to be honest, this is a very cakewalk of a question. All right, Aniket has already answered it while I was speaking. uh, yes, Aniket, thank you, that's correct. Very well done. Okay, so here we go, people. Let's start. First question. Now, a manufacturing unit works 4 shifts in a day, and then the problem talks about the production comparison of the output from one shift versus the other. So there are 4 quantities involved: the production in the first, second, third, and fourth shift. Now, any percentage comparison establishes a ratio between two things. So all I'll do is I'll convert the percentage comparison to ratio. So the production in second shift is 50% more than the first shift. So 50% more means 1.5 times 1.5 is 3 is to 2. Okay, so just to keep some numbers simple, I'm taking as 100, 200 and 300, right? 3 is to 2. So if this is 200 units, this is 300 units done, right? While the production in the third shift was 50% more than in the second shift. So now we can do 50% increase on 300 and reach up to 450 for the third shift. So far, so good. So that's the idea. Just put some numbers that represent the values in the ratio form. Then, if the production in the fourth shift was 50% of that in the third shift, which means half of 450, that would be 225. Hmm. Then the production in the fourth shift, which is this 225, is how much as compared to that in the first shift, which is this 200. So 225 is obviously more than 200. He's asking how much percentage more. So 225 difference is 25 with respect to 200 on the initial base value of 200. So the fractional growth is 25 on 200, or simply this is 1/8, which is 12.5%. Right? Perfect. So the idea being something very basic, elementary, right? Percentage comparison. So you can assign any numbers, any suitable numbers, once you understand the ratio, right? When as soon as he said 50% more, what rings in my mind is the factor of 1.5 times, right? or 3 by 2 or 3 is to 2 is the ratio, right? All right, right? Yes, correct, correct. Let's see. Here we go, people. Next one. So again, something quite related because ratios and percentage are quite synonymous to each other. So yes, I'll give you a few seconds to get this. Okay, so here we go, people. It's about income, it's about expense, it's about saving. Income is expense plus savings, right? So there are three people, Arun, Barun, and Charu, right? Their incomes are given to be in the ratio of 6 is to 7 is to 8, while expenses 5 is to 6 is to 10. Now, before I write these numbers, right, just focus on Charu because we are given that Charu saves 37.5% of her income. If Charu saves 37.5%, the balance 62.5% she spends, that is her expense. So her expense must be 62.5%, which is 5/8 of her income, right? Isn't it? Now look at the numbers that you see over here, for especially for Charu. You see 8 here. If this is 8, we discussed 5 is to 8 should be the ratio of her expense to her income. So 5 by 8. I see here 8 here. So it should be 5 here for the expense, but it is 10. So can I say if I double this ratio, I will be able to connect the uh, income versus expense ratio mutually as well, right? What I'm trying to say, this is 6 is 7 8, right? This is 5 6 8. But how do they compare? That is being established from this 37.5%. Again, yes, correct, Aniket, Fun World, both of you got this correct. Good, good, good. Right. So now, therefore, as I was saying, I double these numbers. 12 is to 14 is to 16, and I double these numbers 5, and I keep these numbers as 5 6 10. Then I can say that this ratio has been interconnected, which means if this is 12x, then this is 14x, then this is 16x, and this has been connected with that ratio 5x, 6x, 10x. So that now you can see 10 by 16 or 5/8 of her income is being spent by Charu. Hence, we can just say that 12 minus 5, which is 7x, is the savings of Arun, while 14 minus 6, which is 8x, is the savings of Barun. And that is being asked that Arun savings, which is 7x, is what percentage of Barun saving, which is 8x. So 7x is how much percentage of 8x? 7 by 8, which is 87.5%. Right? So I think another fundamental problem, I would say, on ratios, how to interconnect multiple ratios. Okay, so this was an easy breeze, but let's see what comes up next. Here we go. Right, TST. Okay, again, I'll give you a minute. The question is on head start, and I'm giving you a 1 minute head start. All right. So yeah, so it's a question on race. In races, the main thing that we are always trying to figure out is the ratio of the speeds of the runners, and that comes basically from the distance that they cover, right? Because in all race problems, time is constant. So the concept that applies is that the ratio of the speeds is the same as the ratio of distance covered, right? Time being fixed, speed is proportional to distance, right? So for A versus B, A gives B a head start of 10 and still beats him by 10, simply telling us that B only ran out of the 200 meters. He ran from the starting, he was 10 meters ahead, so he did not run this 10 meters. And on the finish line, he was 10 meters behind, so he did not get the chance to run that 10 meters. So 10 plus 10, 20 meters. Basically, he ran less with respect to A, whereby A ran the whole of 200 meters. So while A ran 200 meters, in that same time, B basically ran only 180 meters, and hence the ratio of the speeds is 200 is to 180, which is 10 is to 9, right? 10 is to 9, right? Now, if you have any confusion with anything, do let me know. I will repeat it, right? You can let me know in the chat box. Uh, I'm aware, I'm looking on that. Okay. Now, coming to B versus C, in a 400 meters race, B gives C a head start of 10 meters and yet beats him by 15. So again, in a similar way, 10 from here, 15 from here. So he ran 25 meters less as against the whole race of 400. So he ran basically only 375 meters, whereas B ran the full 400 meters race. So in the same time, this is the distance covered by them, 400 versus 375. So the ratio of that is the ratio of their speeds also, which is, remember, we are writing this as the ratio of their speeds. Okay. So we can cancel a factor of 25 on both the sides. So this is 25 into 16. This is 25 into 15. 16 ratio 15. Right. Yes, Aniket, you corrected yourself. That is finally the correct choice. Okay, so therefore, from these ratios that we have got, we can combine them and get the ratio of the speeds of A versus C, because that is what is the main objective. That in a 800 meters race, what will happen, right? So the ratio of speeds of A is to C, we can combine these two ratios and we can say that A by C is A by B times B by C. So we can just multiply these ratios. So 10 by 9 into 16 by 15, which works out to be, simplifying this gives me 16 to the 32, 9 3 is 27. So the ratio of speeds of A is to C is 32 is to 27. What does that tell us? Basically telling us that if this was a race of 32 meters, then C will lose the race by 5 meters, right? The the win margin for A is of 5 meters. So we can just take this ahead in the ratio, because we have to take this to 800 meters. So 32 into 25 is 800. 32 into 5 is 160. 160 into 5 is 800. So just multiplying these numbers with 800 will give me the required win margin, right? So 800 when A will run. So C will run 27 times 25, which is how much? 27 into 25. 25 square is 625, 675, right? So he will run 675, which is 125 meters less, right? So that is the win margin. Perfect. Yeah. So basically, in race problems, ratio of speeds is the main thing that we have to track down, right? And this was all about. Perfect. Okay. Here we go for the next one, people. Something on geometry coming up your way. The figure is also there, right? Some questions in geometry come with a figure, some do not. The ones which do have the figure, the figure already is in front of you and you have to analyze that. So, right, let's go for this. And others also, please participate, everyone. Only a couple of people are active on the chat box. The session is meant for you to practice along with me, right? Okay, let's see, people. So what do we have here? It's an equilateral triangle ABC, and this is called AP, which is obviously the diameter. And then this AB and CP have been extended to meet at Q. The ratio of AP is to CQ is asked. AP is simply the diameter of the circle, right? So that is 2R, right? So we'll keep everything in terms of the radius of the circle. Let's say AP being 2R. Okay. Now focus on triangle APC for the time being. Okay. In the triangle APC, where AP is 2R, obviously this angle is 30 degree. Obviously this angle is 90 degree because it is the angle in a semicircle. So this is a 30, 60, 90 triangle, this APC, in which opposite to 90 degree we have 2R. So opposite to angle P, which is 60 degree, this AC is basically root 3 by 2 times AP, right? Sine theta. So this simply becomes root 3R, right? This becomes root 3R. Now, you might be wondering why I have come to AC, right? See, the thing is that in geometry, whatever is asked is one of the, I mean, what is asked is a end conclusion of going through, finding everything else. So you might not be able to find CQ very directly. Perhaps you first, find this, and then you come to the conclusion. So the point is, in this triangle APC, I have been able to find AC, which is root 3R in terms of R, the radius of the circle. Now, AP is already 2R, which we know will be here, 2R. Now to find CQ, we focus on another triangle which is AQC. And if you look at this carefully, this is another 30, 60, 90 triangle, because obviously QAC, the whole angle is 60, this is 90, so this obviously becomes 30. So we can therefore focus on now finding CQ. So CQ is opposite to 60 degree angle, right? This root 3R is opposite to the 30 degree angle. So remember the ratio of speeds, ratio of sides in a 30, 60, 90 triangle. The ratio of sides, I'm using that ratio, 1 is to root 3 is to 2. So if opposite to 30 degree we have root 3R, then opposite to 60 degree should be root 3 times of that, looking at this ratio. So root 3 times of root 3R, which is this CQ, should be 3R. Hence the ratio becomes 2 is to 3. Right. Fun World, was that a guess? Or did you get that? I wonder how did you get that? Right. It's 2 is to 3. AP is 2R. CQ is turning out to be 3R. Okay. So again, see, I'm bringing the most basic concepts in a new flavor. So 30, 60, 90 triangle is one of the, very frequently used triangle in geometry, right? The ratio of the sides should be known and you should be able to quickly process that, right? So that was the whole theme over here. All right. And obviously the thing that you had to look at this 30, 60, 90 in two different triangles, right? And arrive at the required ratio. All right. So, okay, something on hardcore algebra logarithms. Now, so some standard questions also, we should expect, and this is another such problem. Logarithm, I think, is a very, I would say, know your properties, get it done kind of topic. If you know the things, then there is no hassle in this topic, right? Okay, so let me know if you're able to understand this one. Okay. Well, so here it is, people. Now, so this question is basically about base change property of logarithms, nothing else, right? If you know that, which is that, if there is something like log x to the base a, let's say, and you want to change the base. So this can be written as log x to the base of k if you want to change it to k over log a to the base of k. So that is the base change property. X to the base of a is x to the base of k divided by a to the base of k. Right, so that's what we have to do because what is given is in terms of base 10, but what is asked is in terms of base 18. So you just need to change that in that sense. So this can be written therefore as log 48 to the base of 10 divided by log 18 to the base 10, right? And then you can convert or you can process these numbers in terms of twos and threes because basically you're given the value of 2 and 3, right? So 48 being 16 into 3, right? So you can write this as log base 10 of 16 into 3. So you can write it as plus log base 10 of 3 using again the most elementary property of logarithms, which is log x. Log of x into y is log x plus log y, right? Log of products equals log of sum of equals sum of logarithms of the inputs, right? So therefore 16 into 3, so log 16 plus log 3 divided by again 18 being 2 into 9, so log 2 base 10 plus log 9 base 10. Again, 16 being 2 power 4, and again using the basic property again, that log x power n is n times of log x. So therefore, this being 16 being 2 power 4, and you know that log 2 base 10 is p. So this can simply becomes what? 4 into p, 4 into log 2 base 10, and this is simply q, and this is simply p, and again this is 9, which is 3 square, so 2 comes outside, 2q. Option D is therefore the exact choice over here, right? So elementary properties of logarithms are being used, nothing else. That is all that you need to know, right? Base change property, log xy is log x plus log y, and log x power n is n times log x, right? Okay, here we go, next one. Now, so something interesting is here, people. Sequence and series. I'll give you a minute to try. You can take two as well. Okay, so this one is good algebra, I would say, right? Because what you're given is you're not given directly the formula for the nth term of of this particular sequence. You need to decode that from the given statement, right? It says that from the given average of the first n terms which equals n. Okay, so this is a sequence with the first term as 1 and the average of the first n terms being equal to n. What does that tell us? Average of anything is sum of values upon number of values. So number of values is n, average is also n. Average is sum upon number of values is number of terms is n, average is also n. So average is equal to sum upon n is equal to n, or sum s of n of the first n terms is n square. So the first step is to decode this sequence. The interpretation of this statement becomes sum of n terms is n square. Now, however, am interested in what is the formula for the nth term itself, because only then I can do some processing further with it. I have to find an. Now, given Sn, how to find an? That is the next thing. Can I say an, the nth term, is the sum of n terms minus the sum of n minus 1 terms? Is the interrelationship between the nth term and the sum of n terms of any sequence, not necessarily this particular sequence? You sum till n terms, you sum till n minus 1 terms, you take the difference. That is nothing but the nth term. Yes or no? So, therefore, in the same formula, replace n with n minus 1 and do n square minus Sn minus 1, which is n minus 1 whole square. What do you get? N square minus n square and minus minus plus 2n and minus 1. So 2n minus 1 is the nth term. Means this is the sequence basically of nothing but odd numbers. The first term is 1, the second term is 3, the third term is 5, the fourth term is 7, and so on. This is the sequence 1, 3, 5, 7, 9, 11, dot, 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 right? And therefore, now the question is does not stop here. The question starts from here. First, you had to decode all this, that this is basically the sequence is nothing but odd numbers 1, 3, 5, 7, 9. Now he's saying there's a new sequence which is the square of these terms. You have to find the average of its first 10 terms. Basically asking you to take the average of 1 square, 3 square, 5 square up to 19 square, because 10th term of the sequence will be what? 2 into 10, 20 minus 1, 19. So next our job becomes that our Bn is the sequence which is defined by the terms 1 square, 3 square, 5 square, and so on. We have to find the average of its 10 terms. So we have to find the sum of the first 10 terms of this sequence. Basically meaning we have to find summation of r going from 1 to 10 of 2r minus 1 the whole square. Now in an exam scenario where you do have the on-screen calculator, you can very well just add up these perfect squares, right, quickly. That is one way to do this. But I would say that you should I mean, what if this question was not asking the average of 10 terms, but let's say 50 terms? Then it would have been very difficult for you to do the summation. So you should know how to do such summation without actually calculating, right? Although it is quite manageable, I would say. In the exam scenario, summing these 10 numbers even manually is not too much time consuming. But I will illustrate this, how to do this summation algebraically, which means this is basically summation of r going from 1 to 10 of 4r square minus 4r plus 1. Now I will make use of the summation formulas. Summation of r square, summation of r, we know those formulas. So we make use of that. So this is 4 times of summation of the first 10 natural numbers, square of that. Sum of squares of first n natural numbers is given by the formula n into n plus 1 into 2n plus 1 over 6. So this becomes 10 n into n plus 1, 11 into 2n plus 1, 21 by 6. minus 4 into summation r. R means summation of the natural numbers from 1 to 10, which is n plus 1 by 2. So it becomes 10 into 10 plus 1 by 2. Finally, plus summation 1 means adding 1 10 times, which is simply 10. So you just do this plus minus into, and you get this calculation to be as 1330. And therefore, the answer to this question becomes 133. So it was a two-layered question. First, decoding the sequence based on the summation, right? And next, then taking it further to another sequence, which was the square of those terms, adding them up and finding their average, right? So the moral of this taking this question was: A, you should know how to find the nth term if you know the formula for the sum of n terms. B, you have seen the first 5 questions that I have taken. All of them have been quite doable ones, right? This was a little bit of a speed breaker, isn't it? So in the actual exam, this is something that should be done in the second iteration, right? Right? Meaning this question is doable. I know how to do this, but I know it's going to take 5 minutes of mine, right? So the point is, those questions which are two layered questions, right? This was the two layered questions. First, from the the a1, from for an the initial sequence, it was not given directly what is the sequence all about, right? So you had to decode what's the sequence. Next, then comes to the second sequence, then squaring it, then adding it takes another whole lot of time, right? So doable question, but time consuming, so should be taken in the second iteration, isn't it? Right? Because it's not only that we should know how to solve the questions, we should actually be able to judge which questions are going to eat up on my time. Remember, 40 minutes, that window is there, common for everyone. Who solves more question is not a function only of your knowledge, but of your decision making skills. And that is what I'm here trying to bring home the point: how to select the questions. All right, isn't it? Okay, now let's see what more we have. Right, we have few more. Let's see next one. Here we go. Okay, something on numbers. Hardcore, LCM, least common multiple, blah blah blah. So I'll give you a minute again to take this, right? And let's see who can get this. I'm going to give you one more extra, 1 minute extra, right? So I'll wait for your answer. It's a theta question, you know that, and it's doable. But I'm giving you a little bit of extra time. Well, okay. So Okay, finally Fun World has said awesome answer, Fun World. I would say very well done. Good. All right. Also, although it's a very no, Niket, that's not a thing. I know what you're doing, but you're not taking into consideration the constraint that comes from the HCF. You'll just see, Niket. Just look out for this. Here it goes. Now, so LCM of this is this. Okay, so n. So all these numbers that you see here, 24, 18, 12, 16, 8, all of them involve nothing but powers of 2 and 3, right? So obviously n should also be comprised of the same prime factors, right? N should also be made up of 2s and 3s only. It should be 2 bar something times 3 bar something, only then it can fit into this scenario, right? Now, so the LCM part says, so prime factor, write each number in the prime factorized form. So the LCM of 24 by 24 itself is 8 into 3. 8 is 2 cube. So 2 cube power 24 makes it 2 power 72, and then 3 power 24. That is basically 24 by 24. That is the first number. The second number is 18 raised to 18. 18 is 2 into 3 square, 2 into 9. So 2 power 18 it becomes, and then 3 power, since it's 3 square and whole power 18, so it becomes 3 power 36, right? And the other number 2 power something, and that n, right? The LCM of these numbers is given as 36 raised to 36. 36 is itself is 6 square, so it becomes basically 6 power 72. 6 power 72 is simply 2 power 72, 3 power 72, because 6 is 2 into 3. So in the prime factorized form, this is what it means. Now, for the LCM, we know we take the highest power of all the prime factors. So 2 power 72 is already there in the first number. So 2 power 72 is taken care of, meaning that from perspective of power of 2, the power of 2 over here can be anything up to 72, right? The number n itself need not have any constraint on power of 7 on power of 2. It can, however, it should not cross 72, right? So it can be having 2 power 0 also, that's fine, because 2 power 72 is already coming from the first number. 3 power 72, however, is not there in any of the numbers in given over here. So can I say this power over here must be exactly 72 only, nothing more and nothing less. It does not have any other room. It must be exactly 72. So this is fixed. This right now is fixed, nothing variable about it. The question is all about how many values of n. So obviously the number of values of n are the combination of the powers of 2 and 3. Power of 3 is fixed. Now power of 2, let's see what happens when we look at the HCF. In HCF, we know that we have to take the smallest power of all the common prime factors, right? Amongst the numbers. Now, the first number is 12 power 12. 12 is 4 into 3, 2 square into 3. So whole power 12, 2 square becomes 2 power 24, and 3 becomes 3 power 12. That's the first number. 16 itself is 2 power 4. 2 power 4 whole power 16 is 2 power 64, right? And n is there. And their HCF is 8 power 8, which is nothing but 8 is 2 cube. 8 is 2 cube. So whole power 8, 3 into 8, 24. This is 2 power 24. What does this tell us? So Aniket, here is where you missed the point. If the HCF is 2 power 24, then the number n does need to have 2 power 24 in it. So now the another constraint comes on the power of 2, that it needs to be at least 24. And therefore, n can take how many values is that how many powers of 2 are possible, which is from 24 to 72. The powers of 2 can go from 24 to 72, which are 72 minus 24 plus 1, 49 different values. Hence, n can take 49 different values. What are those values? Those values are of the form that n is 2 raised to power a into 3 raised to power 72. This is fixed, where a can go from 24 to 72. Right? So a very subtle question, right? Testing our fundamental clarity on what is HCF, what is LCM. LCM is taking the highest power of all the prime factors involved. HCF is taking the smallest power amongst all the common prime factors involved. Okay, funny, fun. I mean, I hope this was fun. It was and interesting. Okay, let's take we will last problem for today's session with this one. Here we go. Probability. You can also say PNC, right? Probability basically involves a lot of concepts on counting. Okay, so something interesting again. I'll give you a minute or two until I get some response. We'll see, fun world. We'll see. Okay, so well, how do you do this now? So in any probability question, you have a numerator which is the favorable ways. You have a denominator which is the total ways, right? Total ways is simply the number of ways that we can get different outcomes when a coin is tossed 10 times. So the total number of ways is simply that every time a coin is tossed, there are two possible outcomes, either a head or a tail, and the events are being done in succession. So the fundamental counting principle tells us just keep on multiplying the number of ways every time. So for two ways for the first outcome, two ways for the second, dot dot dot, two ways every time. So 2 into 2 into 2, 10 times 2 raised by 10 or 1024. So that your denominator is 2 raised by 10 or 1024. So that's a simple part. The actual question is, how many ways basically a coin can be tossed 10 times in succession so that no two consecutive outcomes are heads. No two consecutive outcomes are heads. Okay. How many heads do we get? Can we get? That is not specified. How many heads turned up actually is not known. So we have to consider all the possibilities for the number of heads that could have been obtained. So the number of heads can start from as much as even zero. There is no issue in having no heads at all. So in that case, how many ways are possible? Only one way. That is all the 10 outcomes were tails. Based on the number of heads being there, we get the different number of favorable ways. Because we are not given how many heads turned up, so we have to consider all the possibilities. Starting from getting no heads, then getting one head. How many ways can we get one head in those 10 tosses? Obviously, that one head can turn up in any of the 10 positions. No worries, because there is only one head. So in any which way, no two of them, I mean, there are no, the heads are not two in the first instance. So how can they be consecutive, right? So till now, no issues. The issue starts as soon as we write there are two heads. Now the issue starts. And now the counting concept will come into picture. If there are two heads, then there are eight tails. T, 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 dot, 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 eight times. Okay. Now imagine there were three T's. I'm just saying. And there were two heads to come. Says that no two of them are consecutive. They must come in between the gaps around them. So if there were three tails, just let's say for the time being, then can I say one, two, three? There are these four positions where the heads could have come, right? So the point I'm trying to make is, if there are n number of tails, there are n plus one number of gaps in and around them where I can place those heads with no such that no two of them are consecutive. So the gap concept we are making use over here, right? So actually there are eight tails. Eight tails will create nine gaps. Those nine gaps, we need to select two gaps out of them. 9C2. In 9C2 ways, I can select two gaps around the eight tails which appeared where those two heads can come. 9C2 is 9 into 8 by 2 is 36. Now, this concept we'll keep on applying sequentially. The number of tails will keep on reducing, the number of gaps will keep on reducing, the number of heads will keep on increasing. Now we will have seven tails, they will have eight gaps. From those eight gaps, we'll select three gaps. 8C3 number of ways to select three head positions such that no two of them are consecutive in and around the seven tails that appeared. 8C3 is 8 into 7 into 6 upon 6 is 56. Now, this is not going to go very long because actually you will see we cannot have too many heads. You can't have six heads. Six heads and four tails, this constraint can never be satisfied. So there are only two more cases. For four heads, there will be six tails. Six tails will have seven gaps. From those seven gaps, select four gaps. 7C4, which is the same as 7C3 also. You know that NCR is the same as NC and minus R. So 7C4 is the same as 7C3. Is 7 into 6 into 5 upon 6 is basically 35. And last case, because we know we can't have six heads, that is not possible. With six heads, we cannot have them appear in such the way that no two are consecutive, right? Impossible, because there are only going to be four tails. Five heads, so five tails. Five tails, so six gaps. From those six gaps, select five. 6C5 is simply 6, and that is the favorable number of ways, which is 1 plus 10 plus 36 plus 56 plus 35 plus 6. So the favorable number of ways is, my dear friends, this 1, 10, 36, 56, 35, 35 and 6 adds up to 144 out of 1024. So the required probability we have to convert to percentage is 144 on 1024. You know that you can cancel a factor of 16 from here. This is 16 into 9, and this will be 16 into 64. 9 by 64 into 100%. You get this done. This round off comes to be 14%. Right. This question is inspired from a previous year question, a quite a old previous question, right? Uh, that was more of a question on counting. This is more of a question on probability, right? Where no two are consecutive. And the thing that you have to realize is that we could have had any number of heads appearing. So you have to make cases on that, right? And obviously you are limited by the fact that no two are consecutive. So less than or equal to half of them can be heads, right? So you cannot have more than half of the number of being heads. So therefore, your number of cases were not too many, quite manageable. Okay, so this was fun for me, and I hope for you as well. Thank you so much for your participation. Right, but we have 10 people in the room. I was expecting some more people to, stay active with me. The more you practice with me, it would be better for us to learn. And you know I would be happy to respond to any of your doubts along the way. So it's not just a one way show, right? We'll keep on meeting quite regularly, right? So therefore, with that, the hope of meeting quite soon, I'll say thank you so much. Thank you, and we'll see you people again quite soon. Stay in touch, stay connected. All the best. Thank you.